Hi grade 12s and welcome. In this video we're going to solve the mathematics paper 1, which is May-June 2024, which is the supplementary examination. So let us get straight into this paper. What I've done is I've just cropped all these questions into my notebook and we're going to solve all these questions here. Right? So question 1.1.1 says 3x squared plus 5x is equal to 0. In order to solve this problem, remember we need to factorize it. So we can take out x as a common factor, and we left with 3x plus 5, because if you take 3x squared divided by x, we get 3x. 5x divided by x is 5 is equal to 0. Now we have it in factor form, so either x is equal to 0 or x is equal to opposite sign and divided by 3, negative 5 over 3. Right, so pretty simple. Moving on to the next problem, which is 4x squared plus 3x minus 5 is equal to 0. It's already equal to 0, so it's already in standard form. So we will use a quadratic formula, which is x equals minus b plus minus the square root of b squared minus 4ac all over 2a. Now remember to write down what's your values of a, b, c, right? So what's a equals? A is 4, b equals 3, and c equals minus 5. Now we're going to substitute all these values here. When we substitute, just put it in brackets, right? So plus minus the square root of b squared is 3 squared minus 4, a is 4, and c is minus 5, right? And divided by 2 times 4. Right, and now we can just write down the answer, x equals or x equals. Now on the calculator, I'm just going to show you a little trick. After you write everything in the formula, you can just go to mode 5 3, enter the values of a, b, c. A is 4, b is minus b is 3, and c is minus 5, right? And see what answer we get. We get minus 3. We get minus 3 plus root 89 over 8, which is 0,80, 2 decimal places. And the second answer I'm getting is minus 3, so negative 1,55. Right, now that's one way of doing it if you have that calculator. Otherwise, type out this entire thing as we have it here, mode 1. Put your fraction button, so it's minus 3 minus the square root of 3 squared is 9, minus 4 times 4 is 16 times minus 5 divided by 2 times 4 is 8. Right, so I'm not typing the whole thing. As you can see, that's the answer, minus 1,55. Right, and if I change this minus into a plus, I'm getting 0,80. So I hope you guys understood that. Right, so it's nice to have this calculator because it makes life simple. Next problem. We got x minus 1 all squared minus 9 is greater than or equal to 0. I like the way this is written. It's written in the form of difference of 2 squares. So don't try to open this whole thing up. We can just say x minus 1 plus 3 and x minus 1 minus 3. X minus 1 plus 3 and x minus 1 minus 3, because difference of 2 squares. See, it's like a squared minus b squared. And you know what difference of 2 squares is? If you have a squared minus b squared, we write it as a plus b into a minus b. So that's the factorization technique I'm using. It's still greater than or equal to 0. Now put this in brackets. X plus 2 into x minus 4 is greater than or equal to 0. It's a quadratic inequality, so we have to draw a number line and get an answer. Right, so we got minus 2 as critical values and opposite sign here, which is 4. Now if you take any value after 4 and substitute, like the number 10, positive, positive. So because we have one of the signs here and it's linear factors, we can alternate the sign. So plus minus plus. And what's the answers? The answers is greater than or equal to 0. So my answer is equal to 0 and going that way in that direction and going towards the left. If you go towards the left of minus 2, we say x is less than or equal to minus 2. Or if you're going towards the right of 4, we say x is greater than or equal to 4. I hope you guys are understanding. Let's move on to the next problem. So far so good, simple questions. 5 to the power 2x minus 5 to the power x is equal to 0. Now remember a rule that we have is like if you say a to the power x times a to the power x, What is that? Isn't this is a to the power 2x? When you multiply exponents with same bases, we can just add the powers. So that's what I'm going to break up 5 to the power 2x as 5 to the power x times 5 to the power x minus 5 to the power x is equal to 0. Now I can go and take out 5 to the power x as a common factor. So I'm left with 5 to the power x minus 1 is equal to 0, because this one here divided by 5 to the power x is one of that, and minus 1 because 5 to the power x divided by 5 to the power x. Now we know 5 to the power x needs to be equal to 0, or 5 to the power x needs to be equal to 1. Right. Now solving these problems, let's solve this now. Now we know in an exponential function, because this is an exponential function, the answer can never be 0, so we write not applicable. The reason for this is because 5 to the power x is always positive. How we know that? Because if you draw the graph of 5 to the power x, it looks like this, and you can see the range is always positive. So that's the reason why that's not applicable. But over here we can solve, because 1 can be written as 5 to the power 0. We drop the bases and we solve, so x is equal to 0. Therefore x equal to 0 is the only answer. Right, so far so good. I hope you guys are understanding. Right, let's move on to the next problem, which is x over the square root of 20 minus x is equal to 1. Now clearly what we can see here is that the denominator, we have a restriction here. X cannot be equal to 20, so we're just going to write that down for now, and there's more restrictions. Now what we're going to do, because it's a surd equation, we want a surd on one side, so we're going to cross multiply. 1 times root 20 minus x, or 1 times x is x, right? And okay, let's put the root 20 minus x on the left hand side. So we got 20 minus x here, and 1 times x is x by cross multiplication. Now we know that x has to be positive. X has to be greater than or equal to 0, because x has to be greater than or equal to 0, but x cannot be equal to 20, because that was in the denominator originally. Why greater than or equal to 0? Right, so this is the second restriction, taking into account that one as well. So why we're saying that is because the surd, the square root of anything, has to be greater than or equal to 0. The value of x has to be greater than or equal to 0. It must be positive. Anyways, let us continue solving this. So we're squaring both sides, right? Square this side, square this side. When you square both sides, we're getting x squared on the right hand side, and we're getting 20 minus x on the left hand side. Let's put a 0 here and write it in standard form. Bring the x over, so plus x, and bring the 20 over, minus 20. Now I'm going to teach you a trick to factorize on the calculator. But as we see, x times x is x squared, and 5 and 4. 5 times 4 will be 20, alright? So it has to be plus 5 and minus 4. Now therefore x is equal to minus 5, or x is equal to 4. Now let's check if both the answers work. If we substitute minus 5 here, square root of 25 is not equal to minus 5, alright? So that doesn't work. So we're going to say not applicable. If we substitute 4 here, square root of 16 is 4. That's correct. So that's the only one that works. Anyways, using the restriction, we know that the answer for x has to be positive. So clearly x can't be equal to minus 5. Yes, I was talking about a trick on the calculator. Remember how to factorize? Mod 5 3. Value of a is 1, value of b is 1, and the value of c is negative 20. Right? Now see what answer you're getting. 4. So put it back into the bracket. You have to show the step, right? So leave this line, open two brackets, write down the answer. X equals 4, or x equals minus 5, and now switch the signs around. Bring the minus 5 over and the 4 over and put it into brackets. I hope you guys are understanding. Right? Don't forget to leave comments if you have like better methods and stuff. Let's continue on to the next question. We got x plus y equals 9, and 2x squared minus y squared is equal to 7. Now x plus y is equal to 9. X plus y equals to 9. Let's solve for y. So y is equal to 9 minus x, taking this x over. Now because y is 9 minus x, we're going to replace y with 9 minus x. So what we have is, let's take it on this side. We got 2x squared minus 9 minus x all squared is equal to 7. 2x squared minus, open this binomial up, we got 81 minus 18x. How we got minus 18x? 9 times minus x is minus 9x times 2 is minus 18x, and then square the negative x, so you get positive x squared, right, is equal to 7. Now open up this entire bracket. We got 2x squared minus 81 plus 18x minus x squared minus 7 is equal to 0. Where did we get the minus 7 from? From the right hand side. Bring it over. Now 2x squared minus x squared is x squared, 18x, right, and minus 81 minus 7 is minus 88 is equal to 0. Now we can see that this here clearly factorizes, because 11 times 8 is 88, so we're going to write x here and x here is equal to 0. Can we use 11 and 8? Can we use 11 and 8? But using 11 and 8, we can't really get 18 if we add and subtract. So clearly we can't use 11 and 8. So what should we use? So I'm just going to use my calculator to help me out. Mode 5-3. Value of A is 1. Value of B is 18. And value of C is negative 88. Right, so I'm getting 4. I should not be using 11 and 80. I should be using 22 and 4. Right? 22 and 4. So is x plus 22 and minus 4. That's why we're getting x equals 4 or x is equal to negative 22. Let me just show you. We're getting negative 22 there. Yes. Right. Now we're going to substitute the value of 4 in y. So we'll get y equals, we're going to get y equals 9 minus 4, which is 5, or y equals 9 minus 22. So 9 plus 22, which is 31. See, 9 minus 22. So what we're getting? 31. I hope you guys understood that. Right, so nice question. Let's look at this one. This problem here. Whoa, what do we have here now? Right, so if given P is equal to 1 minus A and T is equal to 1 plus A into all of this, determine the value of P times T. What is P times T? Okay, so if we work out P times T, as we see here, we're getting difference of two squares, right? Because you're going to have 1 minus A into 1 plus A and the rest of the terms. Now I want you to think about this. What if we want to factorize 1 minus A squared? We're trying to find a pattern here. 1 minus A squared is 1 minus A into 1 plus A. Right, that's 1. What if we want to factorize 1 minus A to the power 4? So that's 1 minus A squared into 1 plus A squared. Well, we can't factorize this, so what we have is 1 minus A into 1 plus A into 1 plus A squared. And what if we try this for the third one? Let's try for the third one, one more, right? 1 minus A to the power 8. So what we're getting is 1 minus A to the power 4 into 1 plus A to the power 4. So we got a nice trick here. So what we can see here is P times T. Remember, we're going to take this P and multiply by this T. So it's 1 minus A into 1 plus A into 1 plus A squared into 1 plus A to the power 4 dot 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 1 plus A to the power 512. Now you need to just look at the last number, 512. See this number here is 4, that's 8, right? Look at this now, last number, this is 2 and that's 4. It's like double. So the product of all this will just be equal to 1 minus A to the power 512 squared, right? So 1 minus A to the power 512, you should get 1024, right? So that's the value of P times T. I hope you guys understood that. This is a very nice question, thinking problem, because testing you on factorization skills. So this is more like level 4 types, and you gotta have one of those questions in question 1 to make you think. All right, let's move on to question 2. Right, so what do we have in question 2? We have sequence and series. Consider the geometric series 4 plus 2 plus 1 plus half. You can see this geometric series is converging because the ratio. What's the ratio? Does the series converge? Justify your answer. Yes, because the common ratio is 2 divided by 4, which is equal to half. And therefore, minus 1 is less than r, is less than 1. This implies this value of r, okay? This implies series converges. Now the intervals for convergence and divergence is here. I like to use a number line to represent that. So if it's between minus 1 and 1, if the ratio, right, if the ratio is between minus 1 and 1, it will converge. If it's less than minus 1, it will diverge. And if it's greater than 1, it will diverge. Remember, that's not including minus 1 and 1. Right, so I hope you guys understood that. Moving on to the next problem. Calculate sum to infinity. Sum to infinity is a over 1 minus r. The value of a is 4. 1 minus half. 4 divided by half is 8. You can just check that up on the calculator. Let's move on to the next question. Next question is, see what this here says. Next question is basically given. We are given, okay, it's an independent question, totally different from that. We are given that p equals k to 10, or 3 to the power p minus 1 equals 29,520. Calculate the value of k. Now, because this is written in exponential notation, it has to be a geometric series. Let's substitute by, remember how to solve this by opening up the terms. Right, so what's the first term? Remember, we have to open this up. So 3 to the power k minus 1, that's the first value. 3 to the power k minus 1 plus, sigma means plus. Move on to the next value of p, which is k plus 1. So k plus 1, k plus 2, and so on. We're going to move with these values of k, alright? Values of p that we need to choose is, that's values of p that you actually choose. K plus 1, k plus 2, and right up till 10. Now 3 to the power k minus 1, 3 to the power, remember k plus 1 minus 1 is just 3 to the power k, plus 3 to the power k plus 2. If I substitute k plus 2 in p, 2 plus 2 minus 1 is k plus 1, plus dot dot dot, right? And the last value is 3 to the power 10 minus 1, plus 3 to the power 10 minus 1 is 3 to the power 9, and that's equal to 29,520. Now we can see clearly that the value of a, this is the first term, a is 3 to the power k minus 1. The common ratio is term 3 divided by term 2. Don't take this one divided by that when you get negative. 3 to the power k plus 1 divided by 3 to the power k, which is going to give me 3 to the power 1, which is 3, right? And number of terms, n. And what else we need? We need the number of terms, and n is equal to 10 minus k plus 1. 10 minus k plus 1. So last term minus first term plus 1. That's how we find the number of terms. Don't write 10 minus k only. Now we can solve this because that's the SN formula, right? And we can see this, the sum of the series is very large, so I will use divergent formula, a into r to the power n minus 1 over r minus 1, and that's equal to 29,520. So we don't know, well, we know the number of terms, which is 10 minus k plus 1. So a is 3 to the power k plus 1, r is 3, and n is 10 minus k plus 1, right, minus 1 divided by 3 minus 1, right? So divided by 3 minus 1 is equal to 29,520. I'm going to take 29,520 and multiply it by 2. 29,520 multiplied by 2, I'm getting an answer of 59,040. Right, and now for this one we distribute in the bracket, right? Now what happens when we distribute in the bracket? 3 to the power k, we add the powers, so we got 3 to the power k plus 1 plus 10 minus k plus 1 minus 3 to the power k plus 1, because I distributed this in the bracket. Now we are almost getting to the answer, right? So what we can see here is that the k and the minus k cancels out. We got plus 1 and minus 1 cancelling out. No, we got plus 1 plus 10 plus 1. So 3 to the power 12 minus 3 to the power k plus 1 is equal to 59040. Now I'm going to rearrange this. We're going to take 3 to the power k plus 1 on the other side, and we're going to take this over 3 to the power 12 minus 59040. 3 to the power 12 minus 59040. 3 to the power 12 minus 59040. We're getting 472,401. 472,401. Now you can either use logs, okay? You can use logs and you can say this is 3 to the power something. Let's say 3 to the power what? That should be 3 to the power 12. No, it can't be 3 to the power 12. 3 to the power 14. 478,000. 3 to the power 13. 115. Wait, what if you take log of log base 3? 472,401. Why am I getting a negative answer? Alright, let's start again. K minus 1, 3 to the power k, 3 to the power k plus 1. Alright, so I'm just adding 1 to the power is equal to 3 to the power 9. 3 to the power 9, okay, 29,520. Calculate the value of k. This is 3 to the power k minus 1. The value of a is 3 to the power k minus 1. Oh, k minus 1. I wrote a plus 1 here, guys. Okay, so I see where the problem is. There's a minus 1 here. Okay, 3 to the power k minus 1. So I should change this into a minus 1 here. Right, so let me just use a different color. That's minus 1. So we know that minus 1 and plus 1 cancels out. So we just left with 3 to the power 10. 3 to the power 10 here. This is going to be 3 to the power k minus 1 here as well, because we multiply in the bracket. Well, nothing changes here, just this value will change. Right, so we're taking the 3 to the power k minus 1 to the other side. 3 to the power k minus 1, because that was the value of a. See, if you go at the beginning, 3 to the power k minus 1. K minus 1 plus 10 minus k plus 1. Alright, so that cancels out, just left with 3 to the power 10. Alright, so now you're going to take 3 to the power 10 minus 3 to the power 10 minus 59,040. I'm just getting 9. Wow, amazing. Right, so the answer is 9. And 9 can be written as 3 squared. And now drop the bases here. Right, if I drop the bases, therefore k minus 1 is equal to 2. This implies k is equal to 3. Now I'm going to show you this on the calculator. See, there's a nice sigma notation here that you can put, shift sigma, and I'm going to sum up from 3 to 10. Right, and that was 3 to the power, don't use p now, I'm changing the counter to x minus 1, and see what's my answer? 29,520. So I know my answer is correct. Right, so let's continue on to the next problem. Question number 3. Right, so what do we have in question 3? We have that show that the general term of this number pattern is given by, so we have a quadratic sequence, right? We have a quadratic number pattern. So we're gonna write 3, 7, 12, right, and so on. Now to solve this quadratic pattern, we're going to say difference 1, right, and we need difference 2. We already know that this is a quadratic pattern, so we just need 3 terms. So 7 minus 3 is 4, and 12 minus 7 is 5, right, and 5 minus 4 is 1. So we use these 3 formulas. 2a is equal to d2, right. The second formula, 2a equals d2, we use 3a plus b equals d1, and the last formula we use is a plus b plus c equals term 1. A plus b plus c is equal to term 1. So there's your difference 2, right, there's your difference 1, and there's your term 1, because this is your Tn here. Now 2a is equal to 1, so a is equal to half. Why 1? There's your difference 2. Now a is half, so 3 times half is 3 over 2, plus b is equal to difference 1. What is difference 1? 4. And 4 minus 1.5 is 2.5, so b value is 5 over 2. Now if I take half plus 5 over 2, I will get 3. 3 plus c is equal to 3. So therefore c is equal to 0. So remember your Tn formula, an squared plus bn plus c. So what do we have? A is half and b is 5 over 2n. So it's proved. Right, moving on to the next question. What number must be added to Tn minus 1 so that Tn is equal to 13,527? What number must be added to Tn minus, now what is Tn minus 1? So we're going to say Tn minus 1 plus a number. What number must be added? So plus capital N, okay, let's call it x, right, plus x. X is a number, and that's 13,527. Okay, 13,527. What is Tn minus 1? So Tn minus 1, in the place of n, I'm going to substitute n minus 1. So what we have is half into n minus 1 squared plus 5 over 2. What number must be added to Tn minus 1 so that we get 13,527? Don't do Tn minus 1, guys. I have a better option, because you're going to have n and x. You're going to have two unknowns. So let's solve Tn is equal to 13,527. So remember, I'm solving. So what I'm saying is there is a number, there's a quadratic sequence. What was your quadratic sequence? 3. I found another method. Alright, so 3, 7, 12. We have 3. We have a 7. We have a 12. Right, so we need to add some number here. Right, we need to add some number over here. So we get 13,527. Remember, Tn minus 1 occurs here. So the number that you need to add is the difference. See this difference formula here? This number here you need to add. So you get 13,527. Alright, so that's a number you need to add. So let me calculate Tn. Let me equate Tn to 13,527. See what we get. Tn is equal to 13,527. So obviously if this is Tn minus 1, this is Tn. Okay? So 13,527. Tn is half n squared plus 5 over 2n. Right? Now I'm going to multiply this entire equation by 2. So I will get n squared plus 5n minus, remember I need to multiply this by 2. So let me multiply this by 2. 13,527 times 2. I've got an answer of 27,054. Right, now I'm going to factorize this using my calculator, right? Otherwise you have to end up using the quadratic formula if you don't have the silver calculator. So I'm going to say mod 5, 3. A value is 1, B value is 5, C value is negative 27,054. Right, so press equals, I'm getting, don't write x, write n. Remember, n is equal to 164. Check. 162, sorry. 162, or n is equal to, you're going to get two values, negative 167. Right, so let me show you how to put this in brackets. Take that over minus 162 and take that over plus 167. Alright, so we've got these answers. Obviously not applicable since n is not an element of natural numbers. Okay, that's why this is, remember, the values of n is a number pattern, so the values of n can only be discrete, like 1, 2, 3, 4, 5, 6. Now n is equal to 162, so we know Tn is equal to 162. So what is T161? So we know if you substitute 162 in this n formula, we can get 13,527. So work out what is T161. T161 is equal to term 161. Substitute 161 into this, right? Plus 5 over 2 into 161. Right, so let's substitute this into that, mode 1. So half 1 over 2 into 161, close bracket, squared, plus 5 over 2 into 161, right? So I'm getting an answer of 13,363. 13,363. 13,363. So we know we have 13,363 as Tn minus 1. This is 13,363. So 13,527 minus 13,363 is going to give me the number x, right? So therefore, number to be added, number to be added is equal to 13,527 minus 13,363. So we're going to say 13,527 minus 13,363. So we need to add 164. So if we add 164 to 13,000 Tn minus 1, then we'll get 13,527. So I hope you guys understood that. Right, so a very nice question. Next question. Given the arithmetic sequence, we got term 1 which is 8, right? Term 1 is 8 and term 2 is 11. Remember, Tn is equal to a plus n minus 1d. So what is term 8? Term 8 is a plus 7d. And what's term 2? Term 2 is a plus d. Right, so we know a plus d is equal to 8. And term 2 is 11, right? So we know that is 11, which is a plus, term 1 is 8. Term 1 is 8. So a plus 7d. A plus 7d is equal to 8. Right, that's term, wait, this is term 1. Why am I writing this? Term 1 is 8 and term 2 is 11. So term 1 is equal to a, and that's 8. And term 2 is a plus d, which is equal to 11. So we can solve this. A is 8. 8 plus d is equal to 11. This implies d is equal to 3. 11 minus 8. Alright, so we got d value which is 3. Now we want to calculate n if Tn is equal to 41. So Tn is equal to a plus n minus 1d is equal to 41. Right, so it's only 3 marks, simple. So a is 8 plus n minus 1 times d, which is 3, which is equal to 41. Take 41 minus 8 divided by 3, then add 1. So 41 minus 8 is n minus, I'm not going to open this whole thing up, is equal to 41 minus 8. I'm getting 33, and then divided by 3 and add 1. Okay? So if I divide this by 3, I will get 11. Therefore, n equals 12. Right, so I hope you guys understood that. Calculate the value of n if Tn equals 41. Moving on to the next question, which is 3.2.2. That's 3.2.1 and 3.2.2. Right, so it's a sub question of this. Right, so let's see. A new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. For the new sequence P, whoa, what is this? P8 or P8 is 1 and P11 is 2. A new arithmetic sequence P is formed. Using the term position and the term value of the given arithmetic sequence. Term position is here. So what's the arithmetic sequence of the old one? I think this is P8 here. Let me just look at the exam paper. It's not clear. Yeah, that's a 8. P8 is equal to 1. For the a new arithmetic sequence. So P is an arithmetic sequence, okay? So A, in solving A, so this is another question to think about. So the new sequence is P8 equals 1. But now P8 is an arithmetic sequence, so it's A plus 7D is equal to 1. And P11 is A plus 10D is equal to 2. And now if you subtract both, the A's cancel out. 7 minus 10 is minus 3D. 1 minus 2 is minus 1. This implies D is equal to minus 1 over minus 3, which is common difference is 1/3. So write down the value of P41. P41 is now equal to A plus 40D. A, what's the value of A here now? Because if the value of D is 1/3, what's the value of A? Why is it 1 mark? Value of A will be 1 minus 7D. 1 minus 7D. So that's 1 minus 7 over 3. Because 7 times 1/3 is 7 over 3. What is 1 minus 7 over 3? 1 minus 7 over 3. I'm getting negative 4/3. So what's the value of P41? A plus 40D. A is minus 4 over 3 plus 40 times D is 40 over 3. So I'm getting 10. I'm getting 40 minus 4 is 36 over 3, which is 12. 36 over 3, which is 12. I hope you guys understood that. Right? I don't know why it is 1 mark. Are we supposed to think differently? P41 is 12. Do we even have 12 here? What was the old sequence? The old sequence was, what's the value of A? A is 8. 8. We add 3. We get 11. We get 14. we're adding 3 each time, we're getting 17, and so on. Oh, okay, this is switched around. Term 41 is 12. It's like, ah, very nice question. What they're saying here is that, look at this. What this question means is, you see, Tn is equal to 41. Right, so we remember we saw for Tn, which is 12. So T12 is 41. So if I take the value in terms of coordinate form as n as t, n and t, we're getting n. If n is 12, then the value of t is 41. So we want to know in the new sequence, it's like an inverse function. The new sequence is p. So in the new sequence, which is p, you're going to get t and n. Yeah, t is 41, then n is going to be 12. That's why it is 1 mark. Ah, okay. Perfect. So it's like, wow, amazing. This is a very nice question, guys. That's nice level 4 question. Calculate the value of the first term of the new arithmetic sequence. B. Alright, so there was no reason to do all this. Well, we already got the first term of the new arithmetic sequence. The first term is what? Term 1 is... Whoa, we're going to have a problem here. Term 1. Calculate the value of the first term of the new arithmetic sequence. So I kind of have like this idea. Right, so I have this idea, and also we know the old sequence was Tn. The old sequence Tn was what? It was A is 8 and D was 3. So 8, 11, we had 8, 11, 8, 11, 14, and so on. We went right up till 41. Right, so, and 41 was giving me 12 there. This is 3, this is 2, and this is 1. And now in the new sequence Pn, the value is going to be 1, 2, 3, and so on right up till 12. In the new sequence 1, 2, 3 right up till 12. Right, so this is going to be term 8, that's term 11. Term 11 is 2. Yeah, term 11 is 2. Right, so this is the 8th term, that's the 11th term. This is the 8th term, that's the 11th term. This is the 14th term, and this is the 41st term. Right, so we kind of found it here already now. A. No, but that's the 8th term is 1, and the 11th term is 2. What did they say? Calculate the value of the first term of the new arithmetic sequence. 8th term is 1, 11th term is 2. So the value of the first term will be, yeah, so we calculated it here. Yeah, so we already calculated it here. I'm just going to put this answer down. We're just going to write A is equal to minus 4 over 3. A is equal to minus 4 over 3. Calculated above. Okay, let's just put the working here. Right, so we're going to say A is equal to, so term, first term. So we're just going to write the same thing. That's it. Alright, so guys, that's what it was, like a nice inverse function problem. Next question. Right, so next question is on functions. We have the hyperbola function. Write down the equation of the asymptotes. Vertical asymptote is x equals 1. It's always when the denominator is 0. Vertical asymptote, you have to make the denominator equal to 0, so x is equal to 1. And horizontal, the horizontal asymptote is y is equal to 2. Draw the graph of G indicating any intercepts with the axes and asymptotes. Let's find the x and y intercept first. Remember, this graph is in the first and third quadrant because the value of a is positive. Now, you know the general form, y equals a over x minus p plus q. Because the value of a is positive, it's going to be in the first, and if a is positive, then we got quadrant 1 and 3. If a is negative, we got quadrant 2 and 4. Right, so draw a graph. We're going to find the x-intercept here. X-intercept is making g of x equal to 0, so 1 over x minus 1 plus 2 is equal to 0. This implies, take the 2 over, I got 1 over x minus 1 is equal to negative 2. I'm going to cross multiply. If I cross multiply, I will get minus 2 into x minus 1 is equal to 1 times 1, which is 1. We're going to divide both sides by negative 2, so I'm going to get minus half here, right? And then take the 1 over, I will get x is equal to half, minus half plus 1, x equals half. So that's, and my y-intercept is making x 0, so 1 over 0 minus 1 plus 2, which is equal to 1. So 2 minus 1 is 1. Right, so you can check that up. And now we sketch the graph. Remember, when you're sketching this graph, draw your axes first. Then we draw the asymptotes in broken lines. My asymptote is at y equals 2. And my vertical asymptote is at 1. I will neaten this up just now. Right, so I've got 0 here. That's x equals 1. This is y equals 2. Right, so you need to use your pencil and, you know, sketch this graph. Put the asymptotes in broken line, x-axis, y-axis. Right, so let's put the asymptotes in the broken lines. Right, so I've got my asymptote here. Right, and remember the graph is in the first and third quadrant. What makes the quadrants? The asymptote makes the quadrant. So there's quadrant 1, right? There's quadrant 2, there's quadrant 3, and there's quadrant 4. Right, so I hope you understand that. Let's take all this out. So the asymptote makes the quadrants. So I know my graph is in the first quadrant and in the third quadrant. In the first quadrant, I've got nothing intersecting, so I'm just going to draw a graph like this, close to the asymptotes. In the third quadrant, I've got a y-intercept which is 1, and I've got an x-intercept which is half, right? So I'm going to draw this. Okay, so that's my graph, and we can call this the graph of g of x. That's my g of x function. Right, so make sure to draw that, and thus there's the asymptotes. You need to represent this x-intercept as well, which is half. Right, this value is 1, this value is 2. Right, so I hope you guys understood that. Right, so now moving on to the next question, which is determine the values of x where g of x is positive. Where is g of x positive? Now when you're finding g of x positive, make sure to take into account the asymptotes as well. Right, so when is g of x greater than 0? When is the y value is greater than 0 on the g graph? G of x is positive here. Look at where it is positive. All of this. That's where it is positive. So above 0, less than 2. So 0 to 2 or greater than 2. Or x is greater than 2. So that's the answer. Between 0 and 2 and or greater than 2. You can also write your answer there. X is greater than 0 but x is not equal to 2. No, not x. G of x is positive less than half. We're looking for x values, guys. G of x is positive when x is less than half. When x is less than half or when x is greater than 1. You can see all that value is always positive. So if you take any value x less than half, right, or x greater than 1, you'll always get an answer which is positive. Like inside here, substitute the value x less than half, like 0. So 1 over minus 1 plus 2 is the answer is positive. Yeah, so x less than half or x is greater than 1. Yeah, sorry about the previous one. It's not the y values. We're looking for x values. Moving on to the next one. Determine the equation of the axis of symmetry which has a negative gradient. Right, negative gradient is, see this is the equation. Negative gradient is when you do this. Right, so if you just add up all this, you get a positive gradient. Negative gradient is only negative in the denominator. Right, so we're going to look at this function 1 over, so we know we have g of x. Right, so negative gradient is the 1 with the g of x. What was g of x? G of x was 1 over x minus 1 plus 2. So I want negative gradient. I'm just going to put negative in the denominator, right? So axis of symmetry is y equals negative into x minus 1 plus 2, which is negative x minus minus 1 is plus 1 plus 1 plus 2 is plus 3. So negative x plus 3. That's my answer. Right, so that's the axis of symmetry of G. Moving on to the next problem, which is inverse functions. Right, so let's look at this inverse function and try and make sense of it. We got an exponential function and we got an log function. Let's see. In the diagram, f of x is a log function, log x base a. Remember, we got a 0.42, so we can find the value. And g are drawn. Graph of g is a reflection of, right, so because it's a reflection in the line y equals x, you kind of like switching the x and the y value here. So if this was p42 reflecting across the line, you're going to get 24 is somewhere around here. Okay, graph f passes through the point 42 and q is the intercept of f and r in the graph of g. Right, so those are the intercepts. Now write down the coordinates of p prime, the image of p on g. So that's easy. The coordinates of p prime is just switching these two. It's going to become 2 and 4. So the 0.24 is somewhere around here. Not necessarily, because it's reflection around this line here. It should be somewhere around here, 2 and 4. That's where p1 is. So remember, the 0.24 lies on G. Next one, show that A is equal to 2. So we need to solve an equation. What is that? Show that A is equal to 2. So we had f y equals log x base a. Remember, we had y equals log x base a. What point lies on the log graph? The point that lies on the log graph is 4 and 2. right? Now I'm going to, x value is 4 and y value is 2, right? So now a remains a, so a squared is equal to 4. Remember, we have a restriction, a has to be positive. Now you take a square root, you can get plus minus 2. This implies a is equal to 2, since a has to be positive. Right, so when you take a square root, you might put plus minus. So now what? Remember to transform the log. So if I go back and write, remember base remains base in both cases. Exponential base and log base is the same. Right, so when you're switching it around. So I switch this around from logs to exponential. See, like if you have a to the power x is equal to y, right? Then if you're solving for x, it's going to become log y base a. So remember this transformation. Okay, so a is equal to 2, we showed it. Write the equation of g in the form y equals, right? So what was the inverse? We're going to do the transformation here. The inverse function f was y equals log x base 2. So f inverse is x equals, switching the x and the y, log y base 2. So we say y equals 2 to the power x. Right, so that's my function, y equals 2 to the power x, that's g of x. T is a point on f in the first quadrant. Now I need to use a graph to explain this to you. Let's try to make sense of what they're talking about here, right? Otherwise, you know, usually the questions at the end is a little bit challenging, especially this one here, because it's 4 marks now. Right, so this question is a little bit of a challenge, right? So we're going to think about it. T is a point on f in the first quadrant. T is a point on f in the first quadrant where TR is parallel to the x-axis. T is a point on the f where such that TR is parallel to the x-axis. Okay, so right, so remember TR is parallel to the x-axis. That's what I'm trying to draw here. Let me change the color of this line. Alright, so we got TR. Right, so remember this line is parallel to the x-axis. So point T is right here. Okay? Calculate the area of RT prime. Now P prime was here, okay? Which was 2 and 4. Okay, so we can get the coordinates of R, okay? We should start by doing that, because we want to find the area of this triangle here. Yeah, we're basically finding the area of this triangle. We should find the coordinates of R first. Okay, so the coordinates of R is y-intercept, okay? So 2 to the power 0, a y-intercept of g. We got 2 to the power 0, which is 1. So the coordinates of R is 0, 1, okay? Point P1 is 2 and 4. We just have a problem with the base, which is T. T is going to have the same y value, isn't, as R. So the value of T has to be 1, same y value as R. But what's the x value? x value we can calculate. So we can just do half base times height, right? Because the height from there to there is 3. Remember the value of r is 1. And that point there is 2 and 4. So the height is 3. And we just need to find the base. It's easy now because to find t, x, y. So we're going to say use the log function. Y equals log x base 2 at t, x and 1. Right, so x remains x and the y value is 1. So it's going to become x equals 2 to the power 1. So 2 to the power 1 equals x. So the value of x here is 2. Okay, now very nice problem, lovely problem. So now the distance from here to there is 2. So what's area? Area is half. What's the base? 2. And what's the height? Height is 3. So that cancels out. We got 3 units squared. I hope you guys understood that. Very nice problem. Right, let's continue on to the next question. Question 6. Alright, in question 6 we have a parabola and a line. So this should be simple. The graphs of f of x and g of x are drawn. D and E are the intercepts of P and is the y-intercept of f. Right, so you have common x-intercept and common y-intercept. The turning point of f is 1 and negative 4. So you can write that down, 1 and negative 4. And this is my student's paper. So, yeah, so basically, right, and now if the turning point is 1 and negative 4, and then E is 3, 0. How did we get D and E? Remember, we can factor this out, f of x. Okay, let's answer the question. Maybe they're gonna ask us for the coordinates. Write down the range of f. What's the range? Range is, where is this graph sketch? Above minus 4. Range of f, the parabola. So greater than or equal to minus 4. So y is greater than or equal to negative 4. Calculate the coordinates of D and E. Right, so I'm going to do it right there. Calculate the coordinates of D and E. F of x, that's 6.2. We're going to say x squared minus 2x minus 3 is equal to 0. Factor it out. X and x is equal to 0. So we got 3 and 1. Minus 3 plus 1. So x is equal to negative 1 or x is equal to 3. So the coordinates of D is negative 1, 0. And the coordinates of E is 3, 0. Please write it in coordinate form. Right, so that is done. Next question. Determine the equation of G. How are we going to find the equation of G? Well, it passes through the point 3, 0. And what's the y-intercept here? Negative 3. And it passes through the point 3, 0. Right. So let's find the gradient. The gradient is the distance from there to there. Change in y over, so the gradient is just 1. Otherwise, let's say if P, remember point P is minus 3, 0 and point E is 3, 0. If you do y2 minus y1, find the gradient. Gradient is 0 minus 3. Made a mistake with this point P. Point P is 0 and negative 3. 0 and negative 3. Now where did we get 0 and negative 3 from? It's a y-intercept of the parabola, which is minus 3. Right, so we got M. The gradient is 0 minus minus 3. So 0 plus 3 divided by 3 minus 0. So I'm getting 1. And the y-intercept is common y-intercept. So g of x is now equal to x minus 3. Okay, x minus 3. Because the gradient is 1, 1 times x, mx plus c. What is c? Minus 3. Okay, so I hope you guys understood that. Next question. Write down the values of x for which f of x minus g of x is positive. When is the difference between the two graphs greater than 0? So the f graph must be on top and the g graph must be at the bottom, and the difference must be positive. So let's check where it is. True. The difference between f and g must be positive, alright? Let me explain that using, you know, using my pen, so you can attack these problems when you get it again. Right, so the difference between f and g, so f graph must be up and g graph must be down. So f is up and g is down. See over here, this is g minus f. Well, g minus f, we don't want g minus f, we want f minus g. So at e is 0, the difference between the two graphs, but after 3 it is greater than 0. In other words, we can just take g of x over. Where is f of x? Greater than g of x. There, after 3. So x is greater than 3 or less than 0. Or x is less than 0. Okay, that's it. Where's the f graph above? G graph. So you can look at it like this as well. Next question. Determine the maximum vertical distance between h and g if h of x equals negative f of x. If h of x equals negative f of x. So what is h of x? H and g. Alright, the reason why it is 5 marks is because you got to think about which function is above and which function is below. See the way the question is presented here. So we want to know when does the, see, what we want to know is when does this value determine the maximum vertical distance between h and g if h of x is negative f of x. So we want the maximum vertical distance between h and g if h of x equals negative f of x. So h of x is actually equal to negative f of x. So basically it's a reflection on the x-axis. So you reflected this graph on the x-axis. So you have something like this. Remember, minus 3, 0 will become 3, 0. This point will not change because it's just reflecting on the x-axis. Obviously the turning point is somewhere around there. Right, so we're not really interested in the turning point. Right, so this is the graph. And I want to find the maximum vertical distance between h of x and g of x. There's h up and there's g here. So I'm trying to find the maximum vertical distance between h of x and g of x. So is this maximum vertical distance here. Let me use a green color. Right, so see, I'm looking for the maximum vertical distance here. Right, so I don't know where it occurs, so I'm checking. So the maximum vertical distance is, call it d, is going to be the top graph minus the bottom graph. Now the top graph is h of x, right, minus, what's the bottom graph? The bottom graph is g of x. Now let's see, what's the top graph? H of x is negative f of x, so we need to make all these values negative. It's going to become negative x squared plus 2x plus 3. Negative f of x minus g of x. Negative x squared minus 2x minus 3. That was the function. And g of x is x minus 3. X squared minus 2x minus 3. Right. Now, let's simplify this. We have negative x squared plus 2x plus 3 minus x plus 3. So we got negative x squared plus x plus 2x minus x is plus x plus 3 plus 6. Right, so to find the max value, find x max minus b over 2a. Minus b over 2a is minus 1 because value of b is 1. 2 times minus 1. So we just get half. And the value of half is between, determine the maximum vertical, the value of half is between minus 2 and 3. Right, so problem solved. No, we still need to find the maximum vertical distance. So max distance is equal to, take half and substitute inside here. So you're going to say minus into half squared plus, so the maximum vertical distance occurs here at half, minus into half squared plus half plus 6. So we got 6.5 minus quarter. So we'll get 6,25. 6.5 minus quarter, 6.25. You can just check that up on the calculator. So maximum vertical distance is 6,25. I hope you guys understood that. Let's move on to the next problem. Right, so I need the diagram again, right? So let's take the original diagram. Right, so k of x is equal to g of x minus n. K of x is equal to g of x minus n. Determine n if k is a tangent to f. K is tangent to f. If k is tangent to f, that's the equation given. Alright, so if k is a tangent to f, let's find the gradient function. We know f of x is equal to x squared minus 2x minus 3. X squared minus 2x minus 3. We've got x squared minus 2x minus 3. We can say f prime x is now equal to, f prime x is now equal to 2x minus 2, because this here is basically my gradient function. Now if you substitute values here, then you will get gradients. Alright, if you substitute values here, then you will get the gradient of the tangent line. Determine n if k is tangent to f. So how can this here become a tangent? I'm trying to focus here on this line, because they said g of x minus n. Now what is k of x? Remember, k of x is equal to g of x. What is g of x? G of x minus n. What is g of x? X minus 3. X minus 3 minus n. Now if you compare these two, right, if you compare these two here, remember the value of 2 will correlate to the gradient here, which is 1. No, sorry, 1 second. The entire, remember this is a gradient function, so we need a point of contact, right? Yeah, so very nice problem. I like this problem as well. It's a little bit difficult, but very nice. Not that value of 2. Remember, 2x minus 2 is a gradient function, and what's the gradient of k? Right, so the gradient of k is basically equal to 1. And now we need to equate this to the gradient function, because remember, you need to substitute some x value inside here, so you get a gradient 1. And that has to be equal to 2x minus 2. Now you take this minus 2 over, you get 3. So x is now equal to 3 over 2. Now since x is equal to 3 over 2, we can find a point of contact. Point of contact is 3 over 2. Point of contact is 3 over 2, and substitute into f 3 over 2. Let's substitute 3 over 2 into f. 3 over 2 and f of 3 over 2, because we want the y value. Is a tangent to f. It also lies on f. So point of contact is 3 over 2. Let's find f3 over 2, which is 1.5 squared minus 2 times 1.5 minus 3. 3 over 2 is 1.5, right? 1.5 squared minus 2 times 1.5 minus 3. So I'm getting negative 15 over 4. Right, so I've got that answer. I've got a point of contact and I have a gradient. I have a point of contact and the gradient is equal to 1. So now I can find the equation of k of x. Point of contact, no, find the equation of the tangent line here. Equation of tangent line. What's the equation of the tangent line? Y minus y1. So y plus 15 over 4 equals m is 1. m1 into x minus x1. X minus 3 over 2. So if I solve this, I'm going to get y equals x minus 3 over, don't write 3 over 2, convert this into same LCD, minus 6 over 4, 3 over 2, convert it into this LCD. You know, minus 6 over 4 is, the reason why I did this is because I'm going to take that over minus 15 over 4. Okay, it's fine, leave it as 3 over 2, otherwise you will get confused. Minus 3 over 2. Now add up these two terms. Minus 6 minus 15 is minus 21 over 4. But now I want something like this. I need to equate this because I need to find the value of n. Alright, now I've got the equation of the tangent line, right, of k. Right, now I need to equate this to this tangent line here, x minus 3 minus n, because that's the equation of k. Right, so what we see is that the n's cancel out on both sides, the x's cancel out on both sides. We can bring the n over and take the 21 over 4 over, so minus 3 plus 21 over 4. So what's minus 3 plus 21 over 4? Minus 3 plus 21 over 4. Let's take out the answer. Minus 3 plus 21 over 4, which is 9 over 4. So the value of n is 2,25. Right, so nice question. Application question, thinking question. Alright. Yeah, so this was the main theory behind this. The gradient function equated to 1, get the point of contact, find the equation of the tangent line of k, tangent line, equation of the tangent line of k. Right? And now we already know the equation of k, x minus 3 minus n, equate both the equation and then we got our answer. Perfect. Very nice. Let's move on to the next question. Question 7. Right, so 6 years ago, Thabo bought a phone for 13,000 rands. The value of the phone depreciated annually according to the reducing balance method. Right? Reducing balance is the diminishing balance method, so you need to use like that compound formula. Right, the value of the phone is now 8,337.75. Calculate the annual rate of depreciation. So we have a formula, A equals P into 1 minus I to the power n. So what's A? 6 years ago, right? So 6 years ago, Thabo bought a phone for 13,000. So we already know the value of n, which is 6. He bought the phone for 13,000. Now the value of the phone is 8,337.75. So let's calculate that. The value of A, accumulated value is 8,337. comma 75 6 years ago. So that's 1 minus I over 100 to the power 6, and P is 13,000. So we're going to divide this side by 13,000. We will be left with 1 minus I over 100 to the power 6. Alright, so we're going to take the, yeah, so we're going to divide by 13,000 and let's just take the 6th root, right? To the power 6. So you can raise both sides to the power, say 8337,75 over 13,000 and raise both sides to the power 1 over 6, alright? It's the same thing as taking the 6th root. So what I have on this side, left hand side, I've got 1 minus I over 100, and on this side I've got all of this, right? So let me just calculate this value here. I'm going to take the answer to 4 decimal places, alright? So 8,337.75 divided by 13,000 and then to the power 1 over 6. Right, so I've got an answer 0,928647.5. 0,928647, 0.9286 48, 0.9286 4, let's just take the whole thing, 475546. Right, so now I'm going to take this answer over and multiply by 100. So I is equal to 1 minus all of this answer and multiply by 100. So I can just do it in my calculator. 1 minus the answer and then multiply by 100. So I've got 7,13% per annum. Okay, 7,13% per annum. I hope you guys understood that, right? Next question. You don't have to put I over 100 because, you know, if you put percentage here, it means that you're going to take that as a percentage. So just make it I. Should just be I then, because I'm writing I as a percentage either way. Right, so let's keep it like that, simple. Right, so I hope you guys understood that. Moving on to the next problem, question 7.2. See what we have here. Eric and Thandi needs to save 80,000 each to go on a holiday at the end of December 2027. So we have Eric and Thandi need to save 80,000 each. So they need to save up 80,000 each, which is 160,000. Please read carefully. So they need to save up in total 160,000 rands. Thandi decided that she will start saving at the end of January 2025. She will make 36 monthly deposits into a savings account that pays interest of 8.6% per annum compounded monthly. The deposit will be made at the end of each month. Okay, so this is pretty simple, just future value formula. Eric calculates that if he makes 48 deposits of 1,402.31 starting at the end of January 2024, he will have enough money to go on holiday. He will make his deposit into a savings account at the end of each month. The savings account pays interest at 8.6% per annum compounded monthly. Calculate the difference between the total amount that Eric and Thandi will deposit into their respective savings account over the given period. Calculate the difference between the total amount that Eric and Thandi will deposit Okay, first we need to check what's happening with Thandi, right? So for Thandi we need to calculate the future value here, the accumulated value or the future value, right? f equals x into 1 plus I to the power n minus 1 divided by I. Right, so x is, Tanya decides that she will start saving at the end of January 2025. She will make 36 monthly deposit into a savings account that pays interest of 8.6% per annum compounded monthly. So remember how much she's going to save up. We want to calculate x here, right? When you calculate x here, so future value is already 80,000. X into 1 plus I is 8.6% per annum compounded monthly, 8.6 over 1200 to the power 36. That should be 1200. Let's write clearly here. Minus 1 divided by 8.6 over 1200. Now to solve this, we're going to say x is equal to, take 80,000 multiply by 8.6 over 1200 and divided by all of this. Right, so we got monthly installments for Tandi. Put a fraction button. 80,000 times 8.6 over 1200 divided by 1 plus 8.6 over 1200 to the power 36 minus 1. So I'm getting 1955.78. Eric calculates that if he makes 48 deposits of 1,402.31 starting at the end of January 2024, he will have enough money to go on holiday. He will make his deposit into a savings account at the end of each month. The savings account pays interest at 8.6% per annum compounded monthly. Calculate the difference between the total amount that Eric and Tandi will deposit into their respective savings account over the given period. Calculate the difference between the total amount that Eric and Tandi will deposit. So Tandi deposits Tandi's total deposits, right? Tandi's total deposit is equal to 1955.78 times how many deposits she makes? 36. Yeah, please read the question carefully and see what they're asking for. So the total amount that Tandi deposits is 1955.78. What was the answer? Answer was equal to 1955.78 times 36. 1955.78 times 36. She deposits 70,408.08. And what is Eric's total deposits? Tandi's total deposit. Eric's total deposits is, he calculated 14. We don't need to do anything here. 1402.31 times 48. And he deposits 1402.31 times 48. 67,310.88. The reason why Eric deposits less is because he's got more payments, so obviously he'll earn more interest. So what's the difference? That's what they wanted. Difference is Tandy ends up depositing more. So the difference is the difference between these two amounts, right? And I'm just going to take 70,408.08 minus the answer that was stored, and I'm getting 3097.2. 3097.20, right? So let me know, guys, how you have worked it out, right? This is the solution that I can provide. Alright, so I hope you guys are understanding. Alright, so moving on to question 7.3. Lesibana was granted a loan of 225,000. The rate of interest for the loan is 9% per annum compounded monthly. Lesibana will make monthly payments of 5,500 starting exactly 4 months after the loan was granted. So you need to accumulate the loan for 3 months. How many payments will Lesibana make to settle the loan? Right, so very important what you need to do here. Remember, the loan was granted here, payments only starting after the 4th month. So the loan was granted here of 225,000. No payment at 1, no payment at 2, no payment at 3. Payment starts on the 4th month. Lesibana will make monthly payments of 5,500 starting exactly 4 months after the loan is granted. So payment starting here of 55, right? And so on, right up till n. We don't know how long it will take to amortize the loan or to finish off the loan. How many payments? That's what you need to calculate. N will Lesibana make to settle the loan. So what we need to do is it's like she took out a loan. How many payments? Number of payments. We're not calculating the number of months. Then it's after how long. How many payments will Lesibana make to settle the loan? So we just need to work out the number of payments. So we obviously you never make payments for these 3. So you need to accumulate the loan amount here. It's going to get bigger. So let's accumulate the loan amount 225,000 into 1 plus what's the interest rate? 9 over 1200 to the power 3 is equal to, remember the formula we're using the loan formula, and it's 6 marks, right? So nice question. Alright, so remember we are using this formula here, P equals X into 1 minus 1 plus I to the power negative n all over I. Now we can find that in the formula sheet. The X value is 5,500, right, into 1 minus 1 plus I, 9 over 1200 to the power negative n. That's the number of payments that needs to be made to finish off the loan. We wanted the number of payments. How many payments will Lesibana make to settle the loan? Divided by 9 over 1200. Now obviously we need to take this amount divided by 5,500 and multiply by 9 over 1200. So we need to take this amount. Let me just copy and paste here to let you know what we're doing. You need to show some working, okay? So we need to take this amount here, right, divided by 55, Right, so I'm dividing it by 5, right? Let me put a rule off here. And then obviously multiply by 9 over 1200, kind of like cross multiplying here, and multiply by 9 over 1200, just copying and pasting, right? Cross multiply, divide, and then cross multiply. Alright, so multiply by 9 over 1200, and we're going to see what we're getting here. Alright, so obviously when we're entering it into the calculator, we got an answer stored there, right? And that's 1 minus 1 plus 9 over 1200 to the power negative n. We know that we have to take all of this over to the other side, right? Because that's negative, goes to the other side, becomes positive. And we're going to take 1 minus the answer over here, whatever the answer we get is. So let's see what answer we get here. 1 minus, let's see what answer we get. So what we're doing here is fraction 225,000 into 1 plus 9 over 1200 to the power 3 divided by 9 over 1200, right, times 9 over 1200. So the answer I've got is 230,100.56. Why am I getting this answer? Oh, I made a mistake. I'm not supposed to be putting, that's 5,500 in the denominator. That's 5,500 in the denominator, yeah. So I've got 0,313. Okay, I'm just going to put this answer down because that's already stored into my calculator, right? Right, so you're going to put this answer down here. Please don't round off anyway, right? Right, so that's what I have. Now I'm going to say n is equal to, because I've got negative n, I'm going to say n is equal to negative, because I'm using logs, alright? So I'm going to say log of 1 minus this whole thing here, which is 0,3137734,959, and base 1 plus 9 over 1200, 1 plus 9 over 1200. So n is now equal to, let's see, therefore n is now equal to, let's see, so I need to say log, the base is 1 plus 9 over 1200, close bracket, and remember we had 1 minus the answer was stored in 0.31377 was stored in answer, right? And I'm getting an answer of negative, and negative cancelled out. I forgot to put a negative there. So 50,3943, 50,3943, 50,39437595. Right, so what did they say? How many payments will Lesibana make to settle the loan? So you need to round up, right? So you need to say 51 payments. And you can go further and say 50 payments of 5,500 rands each, and one final payment less than 5,500, right? And one final payment less than 5,500 rand. Now I've got a question for you. Find the value of the final payment, which is question 7.4. I'm adding a question for you here. Additional question 7.3. Find the value of the final payment. Right, and I'm going to give you a hint. We use final payment is equal to x into 1 minus 1 plus I to the power negative decimal. What's the decimal? 0.39437595. Negative decimal over the interest rate and into one factor, 1 plus I. That's it. That's your final payment. Right, so I hope you guys are understanding. Right, you work on that and let me know what's the answer in the description box. Question 8. Now we move on to calculus. Determine f prime x from first principles. F of x equals 1 over x. Now this is nice because we're going to use this formula. F prime x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Now I'm going to take this 1 over h out. I like to use this formula. Right? I'm going to take the 1 over h out from here. And what's f of x plus h? 1 over x plus h minus what's f of x? 1 over x. You saw? That's the reason why I took the 1 over h out. So I don't have to keep on ruling off. Now you do LCD here. But because this is totally different from that, we can just cross multiply and put them on the numerator. X times 1 is x, minus 1 times x is minus x, minus 1 times h is minus h, divided by x into x plus h. That's my LCD. Now what I can see is x and the minus x cancels out. We also have more things cancelling out. Right, it's a very simple problem. It's just a matter of doing LCD. I can also see that the h and the h also cancels out. So all I am left with is limit as h approaches 0 of negative 1 over x into x plus h. Now if you substitute 0 inside here for h, you're going to get negative 1 over x squared. I hope you guys understood that. Right, so quite simple. Where did we get the negative 1 from? Because remember, h divided by h is minus 1. Don't cancel it out and make it 0. Moving on to the next problem is first principles. First principles is done. Now we apply differentiation rules. Now very important for differentiation rules is remember these rules here. X of power n, the root of x of power m is x of power m over n, and also negative powers. X of power negative n is 1 over x of power n. Right, so these rules are important in simplifying that. Now we have ddx. What is the square root of 4? It's the square root, right? That's 2. What's the square root of x to the power 6? 6 divided by 2 is 3. What's the square root of 2? Root 2. You can't do anything there, and that's x squared. Now you differentiate. In other words, now you differentiate, because all we did was simplification. Now when you differentiate, you get 6x squared. 2 times 3 is 6. Take away 1 from the power. 2 times root 2 is 2 root 2. And take away 1 from the power, 2 root 2x. I hope you guys understood that. You should get 1 mark for the simplification here, and 1 mark here. Right, so nice question. Let's move on to the next one. Find g prime x if g of x is equal to this. So obviously simple, we use the splitting rule. We can just split up each one over the x squared factor. So we're going to split this up as 3x to the power 4 over x squared minus 4x squared over x squared. Because you got many terms over a single term, you always split it up, plus 6 over x squared. Now let's simplify what's g of x. G of x is 3, 4 minus 2 is 2, 3x squared, minus 4 plus 6x to the power negative 2. Because remember, that's negative exponent, take it up. Now we write g prime x is now equal to 2 times 3 is 6x, derivative of constant is 0, and 6 times minus 2 is minus 12, x to the power negative 3. You can leave your answer like this because they didn't say you must write it in positive exponents and stuff, right? But if you do want to write it in positive exponent form, it should be written like this. that is 6x minus 12 over x cubed. Right, so I'm just gonna bracket this, we don't need it, just stop there. Next question, 8.3. Determine the equation of the tangent to f. The equation of the tangent to f at x equals to 1 is given by y equals 9x minus 9. Now very important again to keep on doing the same thing. Right, so we find f prime x. Now f prime x will give you the gradient function, which is 3x squared, which is 6x plus b. Right, 2 times 3 is 6, take away 1 from the power, 6x plus b. What is this? This is the gradient function. Right. Now, but they already told us is at x is equal to 1. It's fine. If it's at x is equal to 1, which means that they found f prime 1, which is equal to 9. Because remember the gradient, how did you get this gradient in the, question is how did you get this 9? You had to find the derivative at 1 to get 9. Right? That's how you got the gradient of this tangent line. So f prime 1 is equal to 9. Now, but what is f prime 1? 6 times 1 plus b is equal to 9. So therefore, we can write down the value for b, isn't? So the value for b is equal to 3. 9 minus 6. This implies b is equal to 3. Right, so I've solved b. b is now 3. And how are we going to solve at the point of contact? What's happening at the point of contact? At the point of contact, we got f of x is equal to g of x at a point of contact. Right. In other words, at x is equal to 1, you can get f of 1 is equal to g of 1. Right. You can get the same y value at the point of contact. Now, what's f of 1? 3. B was 3, so plus another 3, plus c is equal to what's g of 1? G of 1 is 9 minus 9, which is 0. So therefore c is equal to negative 6. I hope you understood that, guys. Right, perfect. Very nice problems. So far so good. There are some challenging problems here that you got to look at. And don't forget to do that financial maths question that I gave you in the previous. Right, so let's continue here. Next one. Now we have a cubic function. Ax cubed plus bx squared plus cx minus 5. Remember, the y-intercept is minus 5 here. Right, and we can find the equation of this line. You can find the equation of this function because it's turning twice here. So your equation should be x plus 1 all squared into x minus 5. Why all squared at negative 1? Because there's a turning point there. Right, so that's what we're going to do. It's twice. Alright, so that's the method we're going to use to find a, b, c. E, g are the x and intercepts of f. Question number 1. What is question number 1? Show that a equals 1, b equals minus 3 and c equals minus 9. Now you have to show that a is equal to 1, right? So don't guess. So now when you're writing this intercept form, remember we have an intercept form. So what you're going to write, y is equal to a into x plus 1 all squared into x minus 5. I'm using intercept. Right, this is twice. So x plus 1 all squared at we're going to choose a point that lies on this function, which is 0 and negative 5, because I want to solve for the value of a. I'm going to get rid of a and then I can expand this. So y is negative 5, a into negative 5 plus 1, 0 plus 1, so it's just 1, and negative 5 minus negative 5. No, x value is 0, so that's negative 5. So this implies a value is just equal to 1 because I've got minus 5 divided by minus 5. Therefore a equals 1. Now we can choose the value of a as 1 and switch this around. That's x minus 5 into x squared. Open this up. Plus 2x plus 1 Now take the x inside. We got x cubed plus 2x squared, x cubed plus 2x squared plus x, then minus 5x squared minus 10x minus 5. Now if you add up everything, you got x cubed minus 3x squared, add up here, minus 9x minus 5. So the value of a is 1. We don't need to write down the value of a again because that's done above with the y-intercept. We proved it. A is 1, b is equal to negative 3, and c is equal to negative 9. No need to find d because that's given, right? Now calculate the value of x for which f has a local minimum value. Where's the local minimum value? It occurs somewhere around here. Local minimum is here. So you need to find f prime x, okay? It's 4 marks. So f prime x is equal to, remember this was f of x, so 3x squared minus 6x minus 9 is equal to 0. So we have x squared minus 2x minus 3 is equal to 0. Dividing by 3, writing it in standard form. Now we got x minus 3, x plus 1 is equal to 0. Yeah, minus 3 and 1 will work. So x is equal to 3 or x is equal to negative 1. And you can see at x equals negative 1, your y value is 0. It's turning twice and it's a maximum. So when is it a minimum? Minimum at x is equal to 3. Determine the value of x for which f has a local minimum value. So local minimum at x is equal to 3. So you can just write not applicable. Don't write not applicable, just write select max and min, right? So I hope you guys understood this, just factorizing a quadratic. Moving on to the next question. F double prime x times f of x is greater than 0. Now I think I'm just going to use the f double prime x times f of x is greater than 0. So where is this graph? Concave up and positive, or concave down and negative. So what is this? What does f double prime x? So we're looking for negative times negative is positive, but the negative over here means concave down, and this one here means above the x-axis, right? Or you can get positive times negative. Positive here means concave up, and this positive times positive, and this here means above the x-axis. So we're checking for concavity. So first we're going to find where's it concave up. We can take the two x values and divide it by 2. That's 3. So 3 midpoint between these two. No, 3 minus 1 is 2. So you're going to get 1 at 1. That's where. Right, so we're looking for, use the graphs to determine the values of x for which we're looking for negative negative. So looking for concave down and below the x-axis. Concave down and below the x-axis. Yes, the graph is below the x-axis and concave down from here to there, from 1. So let's find the x value of, let's find f double prime x equal to 0. So what's f double prime x? 6x minus 6 equals 0, x equals 1. Right, so we know where it is concave, where it is from here to there. But remember, it says greater than 0, so it's from minus 1 to 1 and less than minus 1. So x is less than minus 1. So I have an answer. X is less than minus 1, or x is between minus 1 and 1, or x is between minus 1 and 1, or what about concave up and positive? Concave up and positive is all here above the x-axis, and concave up, so it's on this side. Remember, concave up and concave down, got to deal with this. This is concave down and negative is below the x-axis, right? And this is concave up and positive, but this is concave up and negative, and the only place where it's concave up and positive is all here after 5. So the intervals are all here after 5. So or x is greater than 5. Now let's see if you get the same answer if we solve this algebraically. Or we know what f double prime x is, 6x minus 6, right? Remember, is f double prime times f is greater than 0. What is f? F is x plus 1 all squared into x minus 5, right? Greater than 0. But we already know that any value of x we substitute here, we're always going to get a positive answer, but still we still have to keep that. Now let's see, we got 3 different roots, 3 different critical values on our number line. I'm just showing you a second method to solve this inequality. You can use the inequality method. Now remember, 6x minus 6 just becomes 6 into x minus 1 into x plus 1 all squared into x minus 5, which is greater than 0. So we kind of solving this. So minus 1, 1 and 5. Those are the important points. Now don't alternate the signs, right? Because we need to check. Right, so you can totally ignore the 6. We're dividing both sides by 6. So any value after 5, you're going to get positive. Any value between 1 and 5, don't substitute here. That's always a positive answer. Any value between 1 and 5, like the number 2, you're going to get negative here and positive there. So you get negative. Any value between 1 and 5, like the number 2, that's positive. 2 minus 1 is positive, and that's negative. So negative product. If I substitute any value between minus 1 and 1, like the number 0, and you get negative here, negative there, I'm getting a positive. Negative, negative, positive. If I substitute any value less than negative 1, like minus 10, negative, negative, getting a positive. So see the problem. See, plus, plus, minus, plus. So be careful. And what answer are we looking for? We're looking for a positive answer. So x is greater than 5, or is between minus 1 and 1, or it is less than minus 1. So that's the 3 answers I had. X is less than minus 1, or minus 1 is minus 1 less than x less than 1, or x is greater than 5. Or graphically I explained that to you, right? So I hope you guys are understanding. Next question. For which values of t will the graph of p of x, which is f of x plus t, have 2 distinct positive roots and 1 negative root? For which values of t will the graph of p of t, it is f of x plus t. F of x plus t, what is f of x plus t? Will have 2 distinct positive roots and 1 negative root. F of x plus t is this entire f of x function, right? And you need to make it equal to f of x equals to t. When you're solving for roots, you need to make solving for roots, okay? Now how do you solve for roots? When you make it equal to 0. So take the t over, you're going to get negative t. Right? Now, it's like solving f of x equals to k, but your k is negative t. Now let's solve using the graph. Remember, I'm going to use the cut method. So I'm going to cut this, horizontally cut this graph at different levels. Right, so let me horizontally cut this graph at different levels and see when do we get 2 distinct positive roots. We want 2 distinct different positive roots and 1 negative root. 2 positive and 1 negative you can only get here. See this y value here, it is -5. So if I cut between the y value and this turning point here, we needed the y value of this turning point. We're going to get it just now. See, two roots are positive and one is negative. So we have to cut between -5, but we can't include -5, right? Yeah, so we're cutting horizontally like this, but you can't cut below this. And there's another one which we can cut just above this, not including this. Alright, so we needed the turning point here, which is 3 and f of 3. So I need to check what is f of 3. F of 3 is 27 minus 3 times 3 squared, 27 minus 27, minus 9 times 3 minus 5. So that's -32. So I've got 3 and -32. So I can only cut between I can only horizontally cut between -32 and -5. Remember, -5 not including, both not including. So -32 less than and -5 here, right? So remember the value of -t that needs to be in there to find roots. Now we need to solve this. Multiply everything by a negative, so the inequality sign changes. So please write it in order. T value needs to be between 32, 5 to 32. So the value of t can be anything between 5 and 32. Now let me see if this answer is correct. If I'm getting 2 positive and any value between 5 and 32 for here. 2 distinct positive roots and 1 negative root, right? I want to see if my answer is correct. Let me substitute a value of t, which is 6, f of x plus t, which is 6. So I'm going to go to equation solver just to check that. Mode 5 and 4. Mode 5, 4. A value is 1. B value is -3. C value is -9. Now remember, I'm choosing a value between 5 and 32, like the number 6. So -5 plus 6. Bring the t over. -5 plus 6. That's 1. Let me see if I'm getting 2 positive, 1 positive, 2 positive, 1 negative. Perfect. Choose any value close to 32. What if I choose 32 here? What if I choose 32? Then you're going to get equal roots. 2 positive, you're going to get equal roots at 32. -5 plus 32 is 27. If I choose 32 here, I'm going to get 27. So let me just change the d value. -5 plus 32, make it 27. See, I'm going to get equal roots. We don't want equal roots. So choose a value less than 32, like let's choose 31. So -5 plus 31, -5 plus 31, 26. Let's change this value of 26. 1 negative, 2 positive. Perfect. Right, so that is my answer. Right, so I'm confident that I know my answer is correct. Right, now question 10. EHGF is a rectangle. HE is produced to x squared centimeters. Let's see what they're saying. EHGF. So EHGF is a rectangle. So that's a 90. If this is B, then this is B, then that's a B, right? HE is produced to N and EH is produced to P, and they are x squared. So the side lengths are x squared. NF produce intersects PG produce at M to form an isosceles triangle. with NM equals MP. Those two sides are equal. Alright, D lies on NP where MD is perpendicular to NP. NP is 4. NP is 4, so the distance from E to H will be 4 minus x squared. Alright, so this will also be 4 minus x squared. Right, 4 minus x squared? No, 4 minus 2x squared, because the entire distance is 4. Minus x squared is minus 2x squared. So 4 minus 2x squared. Right, and B, and MD is 3. MD is equal to 3. Right, so show that the area of EFGH is given by area. So what's the area of the rectangle? EFGH. EFGH. Area of the rectangle is length times breadth. The length is 4 minus 2x squared, and the breadth is B. Now what is B? B is, so we have an isosceles triangle here. Can I apply that information? What is B? How can I find B? What if I put theta here and theta there? If I put theta and theta, then B will become tan theta is B over x squared. Is that helping me? Then I get NF. If that is theta, this is also theta there because corresponding angles. This distance is 3, so this will become 3 minus B. Right? The entire distance is, remember this is B, opposite sides of rectangle, so the entire distance is 3 minus B, this short distance here. That's theta. Is that helpful? No. Let's take out the thetas. Alright, so they gave us 3 and 4. They gave us 3 here and 4 there. So we know the area of the isosceles triangle. What's the area of the isosceles triangle? Area of this entire triangle, area of triangle MNP, is equal to, area of triangle MNP is equal to half, base is 4, and the height is 3, so which is 6. Area of triangle MNP is 6. Then how can we find the area of the rectangle? Area of the rectangle is this. Okay, what if you find the area of MFG? Area of triangle MFG. That's half, base is 4 minus 2x squared, and the height is 3 minus B. Okay, and what about the areas? Okay, so the area of rectangle can be calculated as follows. You can take the area of the full triangle minus this one area here and the second area here and the third area there. So you can say area of rectangle is equal to 6 minus the area of let's write it. So we kind of like have something here now. Say area of rectangle is equal to area of triangle MNP minus area of triangle MFG minus area of triangle FEN minus area of triangle GHP. Okay, now area of rectangle is 4b minus 2x squared b. 4b minus 2x squared b. Area of triangle MNP is 6 minus area of triangle FEN. Oh, MNP. Area of triangle MNP is here. Area of triangle MNP is right here. MFG is this one. Let's take the half into 4 minus 2x squared, so we're going to get 2 minus x squared times 3 minus b, minus area of triangle FEN is half base times height, half x squared b, and same here, minus half x squared b. Okay, so far that's what we have. Alright, now continuing to solve this, we got 4b minus 2x squared b is equal to 6 minus 2 times 3 is 6, 2 times minus b is minus 2b, minus 3x squared plus bx squared. So 6 minus 2b minus 3x squared plus bx squared, minus half is minus 1x squared b. Right, so far that's what I have. Now we got 4b minus 2x squared b is equal to 6 minus 6 plus 2b plus 3x squared minus bx squared minus x squared b. So we got minus bx squared minus bx squared, alright, is the same thing, minus bx squared minus x squared b, and minus 2x squared b. So we can cancel out this on both sides. You can cancel that out with this and this, right, because we got 2 of those on that side and 2 of those on this side. We can cancel the 6 and the minus 6 out, take the 2b over. Right, so basically, okay, the rectangle was constrained in this, the rectangle was constrained in this isosceles triangle where we had the area of the isosceles triangle. So that's the reason why we can do this. So we got 4b minus 2b is 2b, which is equal to 3x squared. This implies b is equal to 3 over 2 x squared. So now the area, now we can find the area. So this implies the area is now equal to, remember I had a b there, so this implies the area is now equal to 3 over x squared into 4 minus 2x squared. 3 over 2 times 4 is 6x squared, that's 1.5 times 4, right, and 1.5 times 2 is 3x to the power 4. Right, so I hope you guys understood that. Right, nice question. Calculate the maximum area of the rectangle EFGH. Right, so we usually know when we're maximizing rectangles we basically get a square, but anyways, let's maximize 10.2 now. So we're going to find a prime x, 12x minus 12x cubed is equal to 0. Take out 12x as a common factor, left with 1 minus x squared is equal to 0. Simplify 12x into 1 plus x into 1 minus x is equal to 0. X is equal to 0, or x is equal to negative 1, or x is equal to 1. So you're going to write not applicable, and this is applicable, because remember x is a distance, x needs to be positive. Right, so we need an answer for x which is basically positive. So the maximum area, either way, if you're looking at this equation, is a cubic function, right? No, that's x to the power 4 function. Yeah, that's basically x to the power 4 function. right? So it's going to be difficult to analyze that, but anyways, this is the, yeah, so at x is equal to 1 is a maximum, right? So at x is equal to 1 is a maximum, so we want to find the maximum area. We're going to say a of 1. This implies a of 1 is equal to 6 minus 3, which is 3 units squared. So max area is equal to 3. So let's not write this. Implies, let's say max area is equal to 3 units squared. I hope you guys understand that. Let's move on to the next problem. Right, so we have two events, right? Probability of A is 0,4, probability of A or B is 0,52. A and B are mutually exclusive. In other words, they're basically disjoint, right? We have the sample space here, and what mutually exclusive means, they are disjoint, they're not touching, right? They don't intersect. Inclusive events means they intersect. So we know the probability of A is 0,4 and probability of A or B is 0,52. So what's the probability of B? Simple, that's 0,12. That's the sample space. So calculate the probability of B. Probability of A or B. Okay, so the probability of A or B is equal to the probability of A plus the probability of B. This is for mutually exclusive. Right. Now A or B is 0,52, probability of A is 0,4, and probability of B has to be, subtract both, right? This implies the probability of B is equal to 0,12. Okay, so I hope you guys are understanding. Right, so next problem. Yeah, so what do we have here? What we have here is a three-way Venn diagram, right? And all the probabilities are given. So great, very simple. The items that a learner bought at a tuck shop were recorded over a period of time. The probabilities of the learner buying a sandwich, a chocolate, and a juice are shown in the Venn diagram below. Right, what is the probability that the learner will buy a sandwich? Sandwich, you need to take all these inside the circle of S. Right, so sandwich is 0,09, 11.2.1. The probability is 0,09 plus 0,02 plus 0,01 plus 0,04. So the 9 and 4, 9%, 4%, 1%, 2%. So that's 3 plus 4 is 7. 7 plus 9 is 16%. So 0,16. Okay, so I hope you guys understood that. 11.2.2, calculate the probability that the learner will buy at least 2 of the 3 items. At least 2 of the 3 items. At least means 2 or more, right? At least 2 of the 3 items, right? So he either buys 2 items or 3 items. Okay, so at least 2 of the 3 items will be this one plus this one plus this one plus that one. So the sum of those 4. You can do it in 2 ways, right? You can do it in 2 ways, or yeah, you can do it two ways. The first way is probability is equal to 2%, let me just write percent, plus 1% plus 4% plus 3%. So you got 1, 2, 3, 4. That's going to be 10%, which is equal to 0, 1. Or you can also work it out like this. What if you combine these two? It's either 2 or more. So if you combine these two, you're going to say 3% plus combine these two 5%, and then combine these two plus 4%, then minus, because you counted this 3 times already, so you need to minus it twice, minus 2 times 1%. Do we get the same answer? 3 and 5, that is 3 and 5, that's 8, 12, 12 minus 2, 10%, yes. So 0, 1. You can also work it out like this, because at least 2 you'll think that it is either 2 is greater than or equal to 2. So he either buys 2 items or 3 items. Calculate the probability that the learner would not buy any of the 3 items. Any of the 3 items will be everything outside the circle. Remember, this entire circle of S was 0, 16, right? So that's already 0, 16. Just add those two. So 11.2.3. The probability will be 1 minus what's on the outside, right? So that's already 0, 16, the entire circle of S. That's 16% plus 23% plus 4%. So we got 16 plus 23 plus 4, 1 minus, right? So we got 16 plus 23 plus 4. I've got 43%, and 1 minus 0.43 is 57. So the answer is 0, 57. 0, 57. Right. So calculate the probability that the learner would not buy any of the 3 items, 0, 5. Or you can just take 1 minus the rest. 1 minus 0.16, because I already summed this up, minus the 0.04, 0.0 to 0.07, right? 0.07, 0.27 minus 0.27. Yeah, so I'm getting 57%. So 0.57 is the probability. I hope you guys understood that. Now question 11.3. 7 guitar players, each with a different name, participate in a concert. So we have 7 players. In how many ways can the names of the guitar players be listed, one below the other, in the program? So we want to arrange 7 names, so 7 factorials, 7 players. So how do we work out 7 factorial? 7 shift factorial. We get an answer which is 5040, 5040 ways. After the performance, the guitar players wait backstage. There is a bench with only room for 4 to sit on. So only 4 players can sit on the bench. What is the probability that the 4 guitar players will be sitting in alphabetical order from left to right? What is the probability that the 4 guitar players will be sitting in alphabetical order? So we got a problem with the alphabetical order, but we want 4 guitar players will be sitting on the bench. Alright, so let's select the 4 players. So 1, 2, 3, 4. So there's 7 ways of selecting in the first position. Then we got 6 players left, then we got 5 players left, and we got 4 players left. Or you can write 7P4. Right, now if you type 7P4, there's a P button, 7 shift P4. What we getting? 840 ways. 840 ways of selecting 4 players that can sit on the bench, right? And even if you try to calculate 7 times 6 times 5 times 4, right? So we got 840. Now, provided you have selected these 4 players, they're just seated, now you want to put them in alphabetical order. So the probability will be, just remember you selected 4 players out of 7, and now they want to sit in alphabetical order, so there's only one way. So 1 out of 840. 40. That's a probability. I hope you guys understood that. And the last and final question. During the performance, the 7 guitar players sit in a line on stage. So we're back to the 7 players, right? 4 guitar players are females. So we got 4 females, right? And 3 males, right? In how many different ways can they be seated if the males may not sit next to each other? If they may not sit next to each other, then how many ways can they sit next to each other? So sitting together, right? What's up? Sitting together. The males must be sitting together. So we got female 1, female 2, female 3, female 4, right? And we got male 1, male 2, male 3. So the 3 males, we putting them together, right? So in how many ways can they sit together? This is basically 3 factorial, right? Now you count them as an entity. So number of ways of them sitting together is 3 factorial, right? Now you count them as a single entity. So they basically can move into different positions in between the females and stuff. So there's 1, 2, 3, 4 females plus 1 entity. So that's 5 factorial. 5 factorial times 3 factorial. So we're going to get this answer out. 5 shift factorial times 3 shift factorial. I've got an answer of 720. Now number of ways males may not sit together. Number of ways males may not sit together is now equal to total number of ways that they can sit together is 7 factorial. That's the total number of ways. Subtract that they are sitting together minus 720. 7 factorial was 5040 as we calculated, minus 720. So 5040 minus 720, 5040 minus 720. So we got 4,320 ways. Okay, so I hope you guys understood this. Don't forget to don't forget to subscribe to my YouTube channel, and all the best, guys.